Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. And today I will be explaining my project for the Industrial Instrumentation final task, created by myself and Kaisa Muhammad Anbiya. So, for the final task, I will be making an automatic industrial door. So, we will be simulating the automatic industrial door with the Logic Expo simulator. And for that case, we need to make ourselves a control block diagram. What is a control block diagram? A control block diagram is a visual representation of the components and connections within a control system. It uses blocks to represent different components like sensors, actuators, controllers, and processors, and arrows to show the flow of signals between them. It helps engineers understand and analyze the control system's functionality. So for our automatic door control block diagram, we have it here. And I'll be explaining each element from the control block diagram. First, we have the sensors. These are the devices that detect various conditions related to the door, such as motion, presence, or obstructions. Examples include motion sensors, limit switches, and infrared sensors. Next, we have the PLC input modules, NI or I/O. These modules are responsible for receiving signals from the sensors and converting them into digital inputs that the PLC can understand. They provide connectivity between the sensors and the PLC processor. And next we have the PLC processor itself. This is the core of the PLC system. It consists of a microprocessor that executes the control program and handles the logic and decision-making tasks based on the inputs received from the input modules. Next, we have the PLC output modules or I/O. These modules take digital output signals from the PLC processor and convert them into appropriate signals to control the actuators. They provide connectivity between the PLC processor and the actuators. And lastly, we have the actuators itself. These are devices that physically control the automatic door based on the signals received from the PLC. Examples include motors, solenoids, or pneumatic cylinders that open and close the door. And here we have the ladder diagram for our automatic door. So for the explanation, the PLC for the automatic door involves several conditions. First, pressing the open button activates the up motor, causing the door to open. The motor will continue running until limit switch 1 detects that the door has reached its fully open position. And then, the door is fully open, LS1 is triggered to indicate its status. At this point, the up motor must be turned off. The up motor can be turned off when the following conditions are: LS1 is triggered, the close button is pressed, and the stop button is pressed. A latch is employed to maintain the state of the up motor, keeping it running until the reset conditions are satisfied. The functionality of the close button is similar to that of the open button. Next, by pressing the close button activates the down motor, causing the door to close. After the door is fully closed, the LS2 is triggered to indicate its status. At this point, the down motor must be turned off. The down motor can be turned off when the following conditions are LS2 is triggered, the open button is pressed, and the stop button is pressed. A latch is used to maintain the state of the down motor, keeping it running until the reset conditions are met. Pressing the stop button halts the motor and activates the ajar lamp, indicating that the door has stopped or is in the process of opening or closing. The reset conditions for the ajar lamp are LS1 and LS2. The close and open buttons serve as the sustained condition to indicate the status of the door, fully open or fully closed. The open lamp output is used when LS1 is triggered, while the closed lamp output is used when LS2 is triggered. These conditions control the operation of the up and down motors. And here we have the simulation and the results for our automatic door for industrial buildings. Here we have the picture when the door is open. Here we have the picture when the door is closed. And here we have the picture when the door is stopped. And that is all for my presentation. And thank you for your attention.